Thank you. Thank you, Anna, and everyone for the opportunity to join you today. Let me give me a moment to share my screen. And let's hope that works. Can you see that okay? Yes? Okay. Well, thank you. Let me see if I can minimize that. Okay. Um, so again, thank you. And I've spent a career working across the whole cadre of different types of perils, and particularly the impacts on communities, on infrastructure, on economies. And this concept of integration is becoming increasingly important, and the network and networks concepts. And from sharing my perspective with you and others today, and hopefully invite questions and discussions, much of our research has historically, and I should say our agencies and organizations, have been historically looking at individual systems, individual projects, flights, instruments, models. But to really have the impact on decision making, we need to put our stories together. And to me, this is really the concept of networks of networks. So I'll discuss that today. And I'm going to talk about a few concepts of what is a network of networks. How is it related to infrastructure, cities, natural resources, and even our shared knowledge? And I'll use an example of going from uh, individual models to models of models to the models of networks. So what is a network of networks? Just trying to, part of my screen is a little blocked, so I'm having trouble seeing it myself. So a network is something that connects two or more networks or groups together. I often remind people to not look at just what is, say, if you were thinking of an organizational chart, not just what is in the box, but the arrows that connect our systems and our networks together. It could be physical that we're talking about, an infrastructure, an energy system, a transportation network. It could be information in a virtual space. And I'll also remind people it could be that social and social economic, cultural networks. In some respects, as we think about more and more data that we're receiving, we think of Internet of Things and how they are connected, whether they're in our homes, in our communities, our neighborhoods, or our global network. And as we heard in the last talk, and I very much appreciate people coming together to create a network of network data depot, data commons, and the tools that's increasingly enabling us to do something. Now, as I said, part of our concern has been decision making to reduce risk, build and develop our resilience. And these networks that we're concerned about can be critical infrastructure. By that, it could be transportation, transportation corridors over land, over sea, our ports, that physical infrastructure that is often disrupted, and we need to be able to reconnect. It could be our energy grids, our electrification of our communities. In some cases, it is critical for our energy supply that impacts our quality of life, our economies, our health and safety. Similarly, it could be our water systems, our water supply networks, our watersheds, which could affect our food, our agriculture, and just our clean access to water. It could be our communication infrastructure. This call and this discussion ourselves could be easily interrupted, but it is a network of networks. It constitutes towers of communications, antennas, satellites, routers, and switches all around the world, which could be disrupted anywhere at any time. And therefore, we need to have a robust capability. Cities themselves, cities, towns, municipalities are in fact networks of networks. That is where we think about disruption and potentially the impacts of perils, social, cultural, economic, but often natural, that can disrupt the connection between these networks of networks. There are a variety of use cases and mechanisms. So the idea, this is not necessarily a new concept. It has been around for a long time, but understanding how to manage these networks, how to monitor them, observe them, model them, the digital twin concepts of new technologies, allowing us to look at these. Here's an example of depictions of two different cases: an energy network with a dependency on the grid, on the supplies, and eventually the utilization. Similarly, a complicated drawing showing a water network and all of the intricacies. And remember what I said, it's not just what's in those boxes or circles. It's the lines. Are they solid lines? Are they solidly connected? Are they dotted lines, meaning they could be disrupted, they're vulnerable, there's exposure, and there's capacity to maintain them and understand them. Data is critical in putting those systems together. But networks of networks can be the infrastructure, the information networks, the knowledge networks, just that, like the depicted here, that connects our brains is really the systems that we are concerned about when we're talking about disasters, about viable economies. The Sendai framework that was referred to in the previous discussion. I was there in 2015 in Japan, and we discussed lessons learned from previous frameworks. And we said it was a time to move from being a victim of disasters and perils to one where we were enabled by information. And what we realized was we had to put the networks together. We had lots of data, we had lots of observations, we had lots of actors who could intervene and take more proactive measures. We had alerting systems, but we didn't really have the network of knowledge. Models of models is just one idea where people have generated models, catastrophic models, infrastructure, exposure, and risk models, a variety of ways of representing systems. But as I said earlier, our research and our funding and our academic institutions have often created thousands of wonderful models. And often we seek proposals and studies and research to create yet another model. But there's incredible value of putting the existing models together to create ensembles, to create networks of models. The models of models together with our networks of knowledge create new concepts of networks as an ensemble of integrated thinking, of integrating and continuing, and again, dependency on tools of putting our data lakes, our data commons, our data depots, our collaborative tools together are creating networks of models. And I'm going to give an example of some work that, in fact, I supported and funded when I was at NASA leading the Disaster Risk and Resilience Program. And I was very thankful to a group that came together originally around, in fact, like the last speaker, concerned about hurricanes and the floods related to hurricanes. It was during the Harvey event that impacted Texas, where we saw a hurricane of incredible scope and scale that hit 4 water basins at the same time. And we realized we had models for each one. We had models of floods at communities. We had global models. but we didn't have a way of putting them all together. And refreshingly, a researcher from that group came to me and said, I don't want to create a new model. I want to integrate the models. I want to be able to answer the questions of not how does the model perform, but the decisions that people were making, which was simply a simple question. Where is the water today? Where is the water going to be tomorrow? Where is the water going to be next week? And as the water was cascading across a large geographical area through multiple towns, cities, infrastructures, and grids, eventually reaching the city of Houston, a large municipal area, and then cascading and flowing into the Gulf of Mexico, we realized we needed a different approach. So the idea was a model of models. This has eventually evolved into a system that, as I will describe before, is now a capability that's reached global scale. An ensemble approach of connecting hydrologic models, hydraulic models, watersheds and basins, and can easily be extended to other models. And we're looking now of the compound perils. What happens when we have that hurricane flood, but in a community that may also be having a heat wave, that may also have a vulnerable electrical grid or health infrastructure. Disaster Aware is a platform supported by the Pacific Disaster Center, which is actually now a global disaster center. Disaster Aware was the first example where we transitioned this research into operational and free and open availability. There's a schematic of what we were thinking as we put systems together. Across the top are examples of different sources of models. The Global Flood Modeling System, the GLOFAST system, which was a flood and model particularly of interest to the agricultural community, the Dartmouth Flood Observatory archives of historical models, and models in different formats and data and scales, combined with the watersheds and watershed tools that were available. Putting these systems together with relative weighting and importance of their contributions to understand the effects on the vulnerability and exposure. And the idea and outcome was to alert potential and realize severity. Again, this concept, and I've been working a lot recently on wildfires and heat, drought. It could be very well extended to the idea of the models of models, which rely on networks and integrated observations of communities of partners across physical, social, and economic communities could be used. And here, again, an example of how it was used and put together for a global flood early warning. Looking across watersheds, assigning the severity to the models to create appropriate warnings or watches, advisories of what may happen, or simply information for situational awareness. This relied on archival data sources from flood observatories, but also near real-time satellite data from optical and from visible, as well as infrared or radar systems. Whatever it constitutes, airborne, ground stations could be part of this. The idea is to work towards this disaster decision-making. And remember, identifying a hazard in and of itself does not necessarily, unless you connect to exposure, vulnerability, and the coping capacity, isn't the full story. And again, that is what networks of networks and integrated science can do. The model of models for flood has been made available around the world through the Disaster Aware platform. It is freely and open available capability, and it can be extended and used by other centers, organizations, and user groups. We're also in a stage now where the group itself, the research and partners, are looking for additional research and partners interested in extending its capabilities. Here's an example of situational awareness. This information was derived from free and open satellite data, combined with local knowledge and regional knowledge, in order to understand the severity of the potential flood hazard. The algorithms that were created, as I showed earlier, were the merging of existing models, matured, tested, and evaluated independently, and now brought together, combined with the infrastructure, the communities, to understand the possible implications of their exposure or vulnerability, and produces a description that explains the combination of where the data of different observations may come together with population centers, or, as I said before, infrastructure, transportation, or other concerns. Currently, the Pacific Disaster Center in Hawaii, which is recognized as a global center, is a platform that incorporates the model of models. It runs all the time. It captures the incidents that happen. It depicts them with appropriate visualization tools, which obviously can be extended through additional partnerships. There's a lot of work and interest now in other communities of taking our data and making not only two-dimensional representations, but our increasing capability to do full kind of 3D representations and visualizations enhanced by artificial intelligence, enhanced by new tools for interpretation. The goal is often near real time. That means looking to making as many processes as automated as possible. Collecting the data as it is created, processing it, often in the cloud, on platforms, in the air, in satellites, or on the ground, but bringing it together to rapidly disseminate. In research, we're often interested in a more detailed and extended time series, because we want the impacts and how it has informed our trends and predictions. And that is also increasingly of interest. The United Nations is using this type of approach, along with departments of defense and security interests. Global flooding is a concern at a defense and security scale all around the world because of its impact on very vulnerable infrastructure and communities, whether they're on coasts, whether they are at embassies, whether they are partners in health, and the fact that water does not know the boundaries of one country to another and flows freely often across. Or there are critical infrastructures, dams, levees, that are part of an important water infrastructure. Disaster-aware platform is available to millions of people, millions of users. We look for partners who have similar platforms and capabilities. In the Americas, where this meeting is being hosted, we often work with the AmeriGeo group, the group on Earth observations for the Americas. There are similar groups in Africa, AfriGeo, and in Asia and Southeast Asia, where the intent is to make available more free and open data. And groups on Earth observations and models have always looked at the disaster community as one that is, as my friends in the State Department have said, is data diplomacy. This is the one example when disasters happen and hazards happen that we drop many of our national security concerns and freely open and share data. And therefore, we need the networks of networks available. And the disaster community is leading the way on establishing open and free or available mechanisms for this access to critical information. Another example, just one specific country, Pakistan floods of recent years. Many parts of our world are not surprised. They are flooded routinely. This is certainly true. I remember meeting the ambassador from Colombia, and we asked what were the major concerns there. And I had the pleasure of being in Cartagena a few years ago for a regional disaster, and it was water issues. And you can go to any country of the world, from Canada, the United States, across the Americas, or in Asia, and water and floods are a common concern. But they're concerned not just because the flood is pure water, they're also concerned because flooding waters become contaminated. They can be toxic, they can be sources for vectors for diseases. They can disrupt our energy supplies, from hydropower to road systems. In the top figure, it shows the distribution of our model alerts, indicating where the level of floods can take place. In 2022 and then 2023, we saw the migration of this to the UN World Food Program, which is a key stakeholder because of their understanding that the infrastructure for distribution and supply of food around the world is drastically impacted by floods, whether in the generation and production of food itself, or seeds, crop generation, or the distribution of food and supplies during and in a disaster, or supplies and distribution for the response, recovery, and restoration. At all stages, this information and networks of networks helps inform this flow of decision-making. Coming back to the US and the hurricane-exposed parts of our country here, Louisiana is an area that's often been impacted by hurricanes, coastal floods, inundation. But as I also mentioned, it's an area of increasing heat waves, vulnerable infrastructure. And the model of models and network of networks and networks of models have all been tested, evaluated, and we are, in fact, had recent discussions with departments of transportation to explore the possibility of including transportation and mobile movement of people, infrastructure, and supplies as an extension of the model of models in this particular case study. Some of the additional future directions here, looking in West Africa, is an example showing the severity levels derived from the model of models and the type of hazard reports that can be provided. Future research can include new sources of data. SAR is synthetic aperture radar. Unlike optical, the radar type of satellites and imagery, or from airborne, can see through clouds. It can see through dust and disturbances. So complementing the indication of the extent and severity of information. In the coming months, sometime this year, we hope to see the launch of the NASA Indian Space Agency satellite, which will open up a new source of SAR data, complements the European contribution of SAR data and those of other countries. The digital elevation models, critical to understanding, as I said, remember the question in Texas, where will the water be? The water is not necessarily where it rained. The water is somewhere downhill. Maybe it is beside critical infrastructure, roads, or other pathways of mobility of people. Operating this process with all manner of imagery, social economic data will require new science teams and motivate new types of research. We will have to derive new algorithms, even if we have existing models, existing networks that are really now about coupling, testing, validating. And one question I might have for the previous speaker is, we are getting better at assembling and collecting data, data depots, data lakes, data commons. But there's a new question arising in this era of artificial intelligence is, can we also make sure this data is authoritative? Where did it come from? What was its pedigree? How can it be trusted? Our networks of networks, again, included that knowledge network. And we need to have confidence and trust, not just the creation of a network in and of itself, but a trusted and authoritative science. Earth observations and models will assist us in moving forward as we are pressured by new questions from climate change, diversity and equity, access to land, to water, to help our populations. Back again in the Sendai framework, it was a recognition that the impacts included incredible displacements of our population, and that understanding disasters and decisions were also about the safety and security of our populations, and particularly those that are in a position of enhanced vulnerability, that may not know that they are in a disaster, but afraid to move to somewhere else because they're not sure that situation is any safer, any more secure. So part of our networks of networks from this discussion of disasters, I try to remind people, it's not just where is the disaster, where is not the disaster? Because people need to mobilize and move very often, but they want to go to a place where there is food, where there is safe water, where there is shelter, where there is protection of their community, and the resources to stay there as long as they need to continue to work, to educate children, to take care of elderly, and make sure the infrastructure can be rebuilt and restabilized for future sustainability. With that, I'll thank you. And obviously, we're open to questions, and we have some time now to hopefully encourage some discussion. So thank you.